Hi guys, welcome to lesson 9.2 quadratic functions. Our objective for this lesson is that I can graph quadratic functions in the form y equals ax squared plus bx plus c. In the quadratic function y equals ax squared plus bx plus c, the value of b affects the position of the axis of symmetry. So if you remember from yesterday or the past 2 days, the a term tells us how wide or narrow the graph is going to be, and it also tells us if it's going to open up or down. The c term is our y-intercept. It's where it's crossing the y-axis, and it's telling us how far up or down our graph is moving in its original form. So today we're going to deal with terms or factors that have b terms in them. So y equals ax squared plus bx plus c, where a is not equal to 0, because if a were 0, this would just be a linear equation. It has a axis of symmetry is at negative b, or sorry, not negative, the opposite of b over 2a, and that also represents the x-coordinate of the vertex, because our vertex, our axis of symmetry, goes through the vertex. Okay? So we're going to take a look at our first equation, y equals negative x squared plus 4x minus 2. So a is going to be negative 1 and b is 4. So our expression here, our equation, opposite of b over 2a. The opposite of 4 is negative 4 over 2 times negative 1. Negative 4 over negative 2 is equal to positive 2. So that gives us the x-coordinate for our vertex. So it's 2 comma something. All right, well, to find the y-coordinate, we need to substitute into our original equation. So negative 2 squared plus 4 times 2 minus 2. So we type that into our calculators, and we get negative 2 squared plus 4 times 2 minus 2. And we get 2. So our vertex is at 2, 2. So I start by putting a point there, and I'm going to use my highlighter and identify where my axis of symmetry is going to be. So my axis of symmetry runs through the x-coordinate of the vertex. Well, now we need to figure out what are some of my y-coordinates. So I know that it's going to be mirrored on both sides, so I'm going to go and use 1, 0, negative 1, and negative 2. So if we type in the opposite, or negative 1 squared plus 4 times 1 minus 2, we get 1. So we have a point at 1, 1. If we plug in 0 for this equation, we get negative 2. That's what we should expect to get, because that is our y-intercept. Okay? If we plug in negative 1 for our x value, remember we need to put it in parentheses. So plus 4 times negative 1 minus 2. So we got a point at negative 7. And negative 2 squared plus 4 times negative 2 minus 2 is equal to negative 14. So we won't be able to graph that last point, but we can graph the other three. So we have a point at 1, 1, 0, negative 2, negative 1, negative 7. Okay. And I know that my axis of symmetry represents the mirror line, so I just need to reflect this across. So if you remember your transformations from last year, reflecting, we're looking how far away is it from our line of reflection, or our axis of symmetry. All right, so now we just need to draw in our curve, just like that. Arrows on the end because it is a line that's going off into infinity. All right, letter B. Our A value is 1. Our B value is -6. So we've got the opposite of B, so the opposite of -6 is +6 over 2 times A, which is 1. So we have 6 over 2, which is 3. So we plug 3 into our equation. We've got 3 squared minus 6 times 3 plus 2, which is -7. So we have 3 and -7. So we have a point at 3, -7. I'm going to color in my axis of symmetry again. All right. So let's use 2, 1, 0. And for the fun of it, -1. So when I type those in, when I plug in 2, we've got -6. When you plug in 1, y is equal to -3. When you substitute 0, you get a 2, which is our y-intercept. And when we plug in -1, remember it needs to be in parentheses, so -1 squared minus 6 times -1 plus 2, and we get 9. So now we can graph our points. So we have 2 and -6, 1 and -3, 0, 2, and -1, 9. So 1, 2, 3, 4, 1, 2, 3, 4. Okay. And we're 3 away there, 1, 2, 3. We're 2 away there, we're 1 away there, and now we can just graph the remainder of our curve. All right. So taking a look down below, we have the function, problem 2 is using the vertical motion model, and the function h is equal to -16t squared plus c is the height of a falling object. We used this in our last lesson. So we're going to tweak it a little bit. So the object that is projected into the air, so it's launched upwards somehow, we call this projectile motion, and it has no other force acting on it other than gravity. The only thing that's happening is gravity, so there's no engines, nothing like that. This model can be represented, h equals -16t squared, -16 is the acceleration due to gravity, plus vt, v is our initial upward velocity, and c is our initial height. So we're going to use that equation on our problem. So we've got a t-shirt being launched at a basketball game with a slingshot into the crowd because, you know, just throwing it in isn't exciting enough. So it's got it's got an upward velocity of 72 feet per second. The t-shirt is caught 35 feet above the court. We want to know how long will it take for it to reach its max, what is the max height, and what is the range. So we got 3 questions we've got to answer. So let's start by finding what our vertex is. So we need our equation, -16t squared plus 72t plus 5, because 5 is our initial height. So we get our vertex, which is the opposite of b, so -72 over 2 times -16a. So we have -72 over -32 is equal to 2.25, and our x value is t, so that's seconds. So one part, how long will it take, we have checked off. Our second part, what is the height? H equals -16. We're going to substitute 2.25 in for x. And we have 2.25 again, and plus 5. So the height is going to be equal to, when you type all that in, 86 feet above the court. So our max height, done. What is my range? Well, the height is going to be at most 86 feet, the lowest the height is going to be? Well, you might be tempted to say 35 because that's where it's caught. But where was it launched from? It was launched from 5 feet off the ground. So the height of that t-shirt is going to be between 5 and 86 feet. Check. All right. Letter B, suppose the height of the t-shirt was launched with an initial upward velocity of 64 feet per second and again was caught 35 feet off the ground. We want to know how long is it going to take in that case. So our equation, h equals negative 16t squared plus 64t plus 5. So we need to find our vertex. We have the opposite of 64 over 2 times negative 16. So that's negative 64 over negative 32, which is equal to 2 seconds. So that's part of our answer. So now we substitute 2 in for t, and we get that h is going to be equal to 69 feet above the court. So our range for this one is 5 is less than or equal to h, which is less than or equal to 69. So it'll be between 5 and 69 feet. All right, letter C. We have Daniel kicking a soccer ball with an initial upward velocity of 64 feet per second. It was 2 feet above the ground when it was kicked. How long will it take to reach its maximum height? So the same thing, h equals negative 16t squared plus 64t plus 2. So our opposite of b, so negative 64 over 2 times negative 16. Well, so it's going to take the same amount of time to get to its maximum height. It'll still take 2 seconds, but it's going to be a different max height, right? Because we're starting with it several feet lower. So we have h equals negative 16 times 2 squared plus 64 times 2 plus 2. Our height is going to be equal to 66 feet. So our, does it ask for our range? No, it doesn't. Okay, so height is 66 feet at its maximum height, and it will take 2 seconds to get there. All right, make sure you fill out your level of understanding. 1 through 4, write down any questions or confusions you may have, and then do make sure you write that summary of what you learned today, how to apply or how to find the vertex, how to use that to graph in a more easy way, and how to use the vertical motion model. See you all in class.